Alright, going to do some pre-calculus problems from section 3.1 about exponential functions and their graphs. The first four we have a little matching, exercise 17 through 20, where number 17, we've got the graph of y equals 2 to the x minus 2. Now the parent graph of this, the graph of 2 to the x, is one of the examples from your notes. Looks like this. Goes through the point 0, 1. So this, if you mess with that, that's going to shift to the right 2 units, and that looks like that's D. And then the second one, we got y equals 2 to the negative x. That's going to flip this over like that. It's going to flip it over the y-axis, and that means it's going to be number A, letter A, and number 19 is 2 to the x minus 4. Having a minus 4 at the end, that means it's going to shift it down 4. That looks like C. I guess the other one's got to be B, but just to make sure, that's 2 to the x plus 1. That's up 1. That's going to be B. Alright, what are we doing next? 21 through 25. Odds. Not with calculator. So we want to graph here the parent graph, and so kind of like what we were just talking about here. I think I'm just going to, well, I'll do them on graph paper. That's what I would want you to do. So I'll set a good example. I'm just going to be lazy and just sketch the graphs, but I should do this. I think that I could go ahead and sketch them on the same set of axes, though, would be okay. So the graph of 3 to the x, if we wanted to make a quick table of a few values here, negative 1, 3 to the negative 1 is 1/3. Got those exponent rules, we have to have those down cold. 3 to the 0 is 1, 3 to the 1 is 3. So that's 1/3, 1, and 3. That gives me the basic idea here, right? All these exponential graphs, if they have not been tweaked in some way, they're all going to have y equals 0 as an asymptote. And then f of x is equal to 3 to the x minus 5. Minus 5, that shifts it to the right by 5. So at this point, 2, 3, 4, 5. There's my same points that I used. I didn't make a new table because I know this is just going to shift it over. So there they are for 21. For 23, we're doing f of x equals 3/5 to the x. Yuck. Alright, that shouldn't be too bad. Going to do the same thing. And I think 3 points should be pretty good for setting this up. Use the same ones. So raising it to the negative 1 power just flips that over. And raising it to the 0 power is 1. Raising it to the first power is 3/5. And raising it to the second power, well, maybe that's enough. We can talk about if we need any more points or not. So 0, 1, that's right there. 5/3, when I plug in negative 1, 5/3 is about here, and then 3/5 is like here. So one thing we might want to note here is that, oh, okay, when this number is less than 1, that makes it look like this, right? It's almost the same as flipping an exponential over the y-axis. Why is that the case? Because this is the same as 5/3 to the negative x. That negative exponent there would flip this over. So these two things, this is two ways of writing the same thing. And now we've got a number bigger than 1, and now that would look more like this, right? Excuse me. All right, so for the second thing, for our g of x function, we have, sorry, I should have called this g of x in this one, because they do in the book. G of x is equal to negative, that flips it upside down, 3/5. When I say upside down, that means it flips it like that. And then I've got an x plus 4. So this is going to make it 4 units left and then upside down. So I'm going to take these points. That's going to go 4 units left, and now instead of being here, it's reflected over the x-axis. 4 units left, reflect here, 4 units left. So going to be down here now. You can go through and make another table, but once you have those, if you understand what the transformations are, it's easier to do it that way, I think. Right? Am I right? Or am I right? So here we've got f of x is equal to 4 to the x. Going to be very similar to 3 to the x. Except when you plug in -1, now you're going to get 1/4. When you plug in 0, you're going to get 1. When you plug in 1, you're going to get 4. 1/4, 4. These exponential graphs get very steep very fast. The next point, if you plugged in 2, it would give you 16, would be all the way up there. So super steep. Does it have a vertical asymptote? No, you can keep plugging in numbers this way, it just gets really, really high up, but there's never a vertical asymptote that it is bounded by. The g of x function, once we have that, is 4 to the x minus 2 minus 3. That's going to shift it to the right by 2, and then this is down 3. So I can just take all my same points. Going to go right 2 and down 3. Right 2, down 3. Right 2, down 3. And then I'm just going to put a dotted line in here because that's where the asymptote, the horizontal asymptote is. And there we have it. So there's my graphs for 21 through 25. Next set, got 29 through 32. And got a little star next to those, which means I'm going to be using my calculator, which I have ready to go right here. I'm going to use a TI-84 Plus for these, but these are just like evaluating things, so this can be done with any scientific calculator. If you have a calculator that you feel like you don't know how to use to do this, just let me know. I can help you out. So for 29, we're doing, the function is f of x is equal to e to the x at x equals 9.2. So that's just, in other words, what is e to the 9.2? And they would like us to round to the nearest thousandth. That's 3 decimal places rounded correctly. Want to see a trick? Your scientific calculator also knows how to do this, probably. You might not know how to set it up to do this, but I'm going to show you on this calculator that if I go into my mode and I go down to float and I choose 3, then it's automatically going to give me things rounded to 3 decimal places, which is the nearest thousandth. So that makes things, I don't know, a little bit easier. There's also, you can do this 2 ways now. I can do E, there's my E, I did second, brought up the E, and then raise it to the what am I doing, 9.2 power, like that. Or I can do this button, that's the e to the x button, because e to the x is such a popular thing to do. It's got its own little thing built in the calculator there, and then put in the 9.2 there. So either way, I'm going to get the same thing. For 30, I'm going to do e, I have f of x is equal to e to the negative x, and x is equal to negative 3/4. So that's the same as negative negative when I plug that in. That's going to be e to the 3/4. Just got to be careful with the signs there. E to the 3/4, which is 2.117. Don't even have to worry about rounding because I told the calculator how I want it. And then I've got this g of x is equal to, do you notice how I'm like writing out each problem? This is what you should be doing. This is good practice, good math. Not just like writing down the answer. I know you're rolling your eyes at that, but it's the way good mathematicians roll. 4 times 0.02. And one more button pushing problem for now. H of x is negative 5.5 e to the negative x, and x is equal to 200, so that means we need to do negative 5.5 e to the negative 200, negative 5.5 e to the negative 200. Ooh, that's a small number. So rounded to the nearest thousandth. If you think about, this means like times 10 to the negative 87th power. So rounded to the nearest thousandth, that's actually just 0, because this is like 0.0000086 zeros, and then these numbers start happening. So if we want to play by their rules, round to the nearest thousandth, that is equal to 0, because that's so small. Let's see, 33. No asterisk here, so I'll put the calculator away for a minute. Graphing, again, graphing an exponential function. Directions here say use a graphing utility to construct a table of values and then sketch. I'm just going to do it by hand. I asked you to do these without calculator, so I will. What are we doing? 33 through 39. So 4 of these. 33. I'm going to do them just like I did those problems, like 21 through 25. I'm going to make a little table by hand. It should be easy enough. Like, I really think that you only need the 3 points for these. If I do -1, 0, and 1, I might adjust what these values are if there's something happening to the x, like an x minus 1 or whatever. I'll talk about that if we get there. So raising 5 over 2 to the -1 power flips it over. That's just 1, and that's 5 over 2. So when I plug in -1, I get 2/5. When I plug in 0, I get 1. When I plug in 1, I get so there we go. Just respect the steepness. They're going to get real steep real fast. Number 35, 6. Do we even need to make a table for this? Come on. You see what's happening. When I raise it to the -1, I'm going to get 1/6, and then I'm going to get 1, because 6 to the 0 is 1, and then I'm going to get 1, 2, 3, 4, 5, 6, and I'm going to draw that in and respect how steep that's getting there. 37. Okay, so here, for example, my function is 3 to the x plus 2. So the thing that I want to put in the middle is like the 0 that would go with this, -2, and then I'm going to do 1 point on either side of that. Excuse me. That's because -2 is like the new 0 because of the plus 2. That makes sense? Because now when I plug -2 in, that's the thing that gives me 3 to the 0. That's what gives me 1, just like that did. When I plug in -1 here, that's 3 to the first power, and then 3 to the -1, that's 1/3. I should have put those the other way around. I think I would have liked that better that way, because -3, -2, -1, but you can handle that, right? So at -2, that's where I have my 1. At -3, I have 1/3, and at -1, I have 3. So there we go. $39. We got 3 to the x minus 2 plus 1. Three to the x minus 2 plus 1. So 2 is the new 0, and then I'll do the 2 points on either side. I've got a plus 1 now, so just be careful here. So 3 to the 2 minus 2, that's 3 to the 0 is 1, plus 1 is 2. And then when I plug 1 in, I get 3 to the -1, that's 1/3 plus 1. You could either write that as 4/3 or 1 1/3, I think is perfectly helpful here. And then when I plug 3 in, I get 4. Right? Nope, just kidding. Hold on. Yes, that's right, sorry. I plug 3 in, 3 to the 1, that's 3 plus 1, so that's right. I need to include, always, if there's any asymptotes that are not the axes, here my horizontal asymptote that's usually on the x-axis got moved up 1, and now I've got, when I plugged in 1, I got 1 1/3. When I plug in 2, I get 2. When I plug in 3, I get 4. And there we go. Not hard to do. I'm going to skip. Oh, I'm not skipping anything. I'm just using the calculator now to get my points. So I'm going to do these ones more like what the directions said. I'm going to try to graph it by hand, but I'm going to use the calculator to get my numbers. I'm going to show you something cool. Actually, I don't know, maybe you already know how to do this, and maybe you don't know, and you're going to be like, yeah, I don't think that's cool, but whatever. It's a good thing to know how to do with your calculator for sure. So I'm going to go ahead and enter for 41. That's my function, e to the -x. And then I'm going to set my table. I want my table to start. 0 is always a good place to start. And then delta table, that's just what your table goes up by. So I don't know if you've ever looked at this menu. This is like just to tell the table how to set itself up. It's given me the 3 decimal places because I still have it in that mode. Okay, so if I look for my -1 to 1 points here, and how do I know that those are the ones I should be looking at? Well, here we've got f of x is equal to e to the -x. There's nothing happening. There's no like plus or minus with the x, so I'm not centering it at a different place besides 0. There's no plus or minus like there was here, for example. Here it was x minus 2, so I centered my table at 2. Here, no plus or minus, just going to center it at 0. And then I'm going to get these numbers from the table. When I plug in -1, I get 2.718. When I plug in 0, I get 1. And here I get 0.368. So I'll do my best to graph those. 1.36801, negative 1, 2.7, blah, blah, blah. There we go. I think I can fit another one down here. Let's see. So, got f of x equal to 3e to the x plus 4. So negative 4 should be the middle thing in my table. Negative 5 and negative 3, round that. Should be enough to get the shape. I'm going to go back to my y equals, and this time I want 3e to the x plus 4. And delete this other junk. Looks good. Going to go to my table, and I want the negative 5 through negative 3 there. So it looks like I've got 1.13 and 8.2. I can't do better than, for graphing purposes, than to the nearest tenth, so that's why I'm rounding to those. So let's see. Negative 5, 1, 2, 3, 4, 5 is at 1.1. Negative 4, 3, negative 3, 1, 2, 3, 4, 5, 6, 7, 8.2. So there. Question, where's the horizontal asymptote? Well, there's no plus or minus back here, so the horizontal asymptote is still the x-axis. That only moves if we have like a plus or minus, like we did here. That plus 1 moved it up. All right, let's see, we're doing 45 and 47. We are. We got 2 plus e to the x minus 5. E to the x minus 5. The table, let me go ahead and get that set up here. Plus e to the x minus 5. So the 0 of this is 5, so that should be the middle of my table. So I'll do 4, 5, 6. Going to get to that part of the table. 4, 5, 6. So I got 2.3, 2.4, that would round to. 3 and 4.7. And because of the plus 2 here, that does move my horizontal asymptote up. So I'm going to put my dotted line there. I've got 5, 3, 4, 2.4, 6, 1, 2, 3, 4.7. I'm crashing into my table here. Oh well. So there's that. 47. I got 2e to the 0.12t. 2e to the 0.12. And they call this s of t instead of f of x. Doesn't change anything, just names of things. Still going to plot it in the same way. So there's no plus or minus here. So that means I'm still centered at 0, -1 and 1. So let's go ahead and put that in at 2e to the 0.12 t. I'm going to do it with x's here because that's what the calculator defaults to. Go to the table, and want my -1 is 1.8, 2, and 2.3 if I round to the nearest tenth. Okay, so 0, 2. It's not 0, 1 because of that multiple there. And then -1, 1.8, and at 1, it's 2.3. So if you're looking at those points and you're thinking, that doesn't look super steep like one of these, well, a number like much less than 1 there as a multiple is going to really drag that out. It is still an exponential curve, and I'm still happy with the 3 points there, but now it's not going to get to the real steep part nearly as fast. All right, that's the end of that set. Calculator is still going to be involved for the rest of them. 53 and 54, finding points of intersection. This is a thing you need to know how to do. There's lots of applications for this sort of thing. And this is really all calculator work. So let me talk you through how to do this. Maybe you already know. So I'm going to put in here for number 53, I'm going to put in these two y equals that they gave me. They gave me 20 e to the 0.05 x and the horizontal line at 1500. This is, by the way, the same if you're trying to find where these two things intersect. You're finding where these two things are equal to each other. You're basically solving this equation right here, where those two things intersect is where these two things are equal to each other. It's a good trick. If you've got a calculator and you're trying to solve some equation, then put each side of the equation into your calculator and find the intersection. That's your solution. So before I hit the graph button, if I hit the graph button, who knows what's going to happen, but it's probably not going to be good. It's probably not going to be that useful for us here. So just thinking about what we're looking at here, the y value here, the intersection that I'm looking for, is 1500, right? So in my window, I need to be able to see where 1500 is. Right now my y values that are being graphed are from 0 to 5. If you're in your default window, it might be like -10 to 10, -10 to 10. That's totally useless because I need to see 1500 in there. So this is what I'm going to do. I'm going to go from 0 to, I don't want to just go to 1500. I'd like to see above that. This is not the only way to do it, but I'm going to go from 0 to 2000. And then this y scale, that's like where it makes marks on the axis. So if I was going to graph this and I wanted to go up to 2000, I'd probably go 1, 2, 3, 4 and make them like 500s. Does that make sense? So I'm going to tell it to do the y scale by 500s. So we should see 4 of those as it goes up. For the x values, I don't know what x value is going to make this equal to that. So I'm going to start, I do know it's going to be positive. I'm going to start with 0 and say 0 to, I don't know, what do you think, 100? I mean, maybe you just thought it was 10 and then you could try the graph. Okay, so I think it's very possible that for a student to look at this graph and be like, okay, what the heck just happened there? Well, it graphs them in order. So it graphed this first. So this thing, as it traced along the axis, this is so low compared to my 2000 here that it didn't even show up. What does that mean? It means that in my window here, I need to have x values that are like way bigger, way bigger. So I could go up. When I say way bigger, don't turn the 10 into a 20. Add a 0. Try again. Oh, I think we got it. If that wasn't big enough, I'd go back to the window and add another 0, and so on. But it looks like we got it. And then to find the intersection, I'm going to go second, calculate, second, get the calculate menu, and I'm looking for the intersection. It's going to ask you first curve, second curve, because you could have more things in your y equals menu than just 2, but I only have 2 in there, so I just need to hit enter, 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 enter 3 times, and there's my intersection. It's at x is equal to 86.35. So number 54, going to try to do the same thing. Go back into my y equals. I'm going to clear that one out. Now I have 100 e to the 0.01x, and want to know when that's equal to 12,500. Okay, so I'm going to reset my window. I need to get up to 12,500, so maybe I could go up to 15,000. That's an option. You could do 20,000, whatever. It's up to you. It just needs to be bigger than whatever the y value is. And I'll try this again, 0 to 100, and see. So it looks like same problem. This is way too low. So that means I need to go back to my window, and my x values I need to be bigger. So I'm going to add a 0 to that. There we go. That looks good. All right, we got it. So looking for that intersection. Second, calculate. Intersection is number 5. And first curve, second curve, guess. 482.831. All right, that's those two. And then 57 to 64, we're going to do with our calculator. I'm going to fill in a table here for compound interest. So I think I'm actually, because I'm about to get a bell here, I'm going to put these last 8 problems in a second video for you. So just look for that second video, and we'll cut this one off right here. Bye.